Welcome today, folks. We're going to talk about empirical and molecular formulas. So first things first, we need to think about what exactly those are. Well, if we're thinking about empirical molecular formulas, empirical formula is the reduced formula, where molecular is an expanded formula. It's not been reduced, not reduced. To give you an example of this, we could do something as simple as a sugar or any really carbon compound. So if we have a empirical formula of CH2O, a molecular example of that, well, it still has CH and O, but they're by a multiple, by a factor. So we could say that another one would be C2H4O2. Now notice that all of these have been multiplied by 2. It's still a valid formula. It's just a molecular formula because this molecule would have the same empirical formula as that. We could do one where we take it times 3, where we have C3H6O3. Okay, it's just one where if there can be multiple formulas involving the same 3 elements, we need to really look at the percentages that are involved. So let's get started and find out how we talk about an empirical formula, how we find an empirical formula. Okay, so here's our first question. Calculate the empirical formula for a compound with a percent composition of 94.1% and oxygen and 5.9% hydrogen. Okay, so here we have something that we learned last unit, or last section of this unit was percent composition. Okay, so the way to go about solving these is to assume that we have 100 grams of whatever compound this is. If we have 100 grams of it and 94.1% of that is oxygen, we know that there are 94.1 grams of oxygen in that 100 grams. Okay, so step 1 is just convert to grams, or not convert, but change to grams. Step 2 is calculate moles. And since we did this with oxygen, we're also going to do this with hydrogen. So we have 5.9 grams of hydrogen here. Okay, so we need to convert these to moles. So in 1 mole, we have of oxygen 16.00 grams. That allows grams to cancel. And hydrogen, for 1 mole of hydrogen, we have 1.01 grams. So once again, grams cancel. So now we're just simply calculating how many moles of each we have. So let's get our calculator out here. Okay, so 94.1 divided by 16.00 equals 5.88. So we have 5.88 moles. Then let's calculate for our hydrogen now. So 5.9 divided by 1.01 equals 5.84. Okay, now once we have calculated the number of moles, we divide both. As step 3, divide both by lowest number of moles. Okay, so we have 5.88, 5.84. We're going to divide both of them by 5.84. Now, here's where we get into a little bit where normally in chemistry we're so exact. Here we can do a little bit of rounding. Well, 5.84 divided by 5.84 is 1. 5.88 divided by 5.84 is going to be 1.0 something. Well, really for our intents and purposes here, it is just simply 1. Okay, so that gives us our molecular formula, or the empirical formula, sorry. That gives us our empirical formula. The empirical formula for this is simply HO. Okay, so let's go ahead and try another one here. Calculate the empirical formula of a compound with 67.6% mercury, 10.8% sulfur, and 21.6% oxygen. So let's go ahead and get started with this here then. So we assume, once again, first step is assume that it's out of 100 grams. So 67.6 grams of mercury. And the molar mass here of mercury is right down here, is 200.59, right in here. It's 200.59 grams in 1 mole. Okay, then we have 10.8 grams of sulfur. Sulfur in 1 mole. We end up having 32.07. 32.07 grams. And then oxygen, 21.6 grams of oxygen. 1 mole of oxygen is 16.00 grams. So we go ahead and we're going to go forth and calculate all these. Okay, so calculator out. Here we go. 67.6 divided by 200.59 equals 0.337. So 0.337 moles. Our next one, we have 10.8 divided by 32.07, and that equals 0.337. 0.337 mole. And then finally we have, sorry, let me get my calculator out, 21.6 divided by 16, and that equals 1.35. 1.35 moles. So we then divide each one of them by the lowest number of moles. Well, we have two that are the same here. So 0.337, 0.337, 0.337. So we know that there is going to be 1 mercury, 1 sulfur, and let's find out how many oxygens we have in our empirical formula here. So 1.35 divided by 0.337 equals 4.00. So basically just simply 4. So our empirical formula for this is HgSO4, mercury sulfate. Okay? So let's keep on moving forward here. Now we're talking about molecular. Okay, what is the molecular formula for a compound whose empirical formula is CH2O and has a molecular mass, a molar mass of 90 grams per mole? So if we're trying to find the molecular formula, we're given its empirical formula, we're given its molar mass. First thing we need to do is calculate its the empirical formula's molar mass. So the empirical formula is CH2O. We need to calculate that mass. Well, carbon is 12.01. Hydrogen is 1.01, in this case, times 2. And then oxygen is 16.00. So we have 12.01 plus 2.02 plus 16, and that equals 30.03. So once we found the empirical formula, okay, which is this right here, to find the molecular formula, what we do is take our molar mass of the molecular formula, which is 90, and divide that by our empirical formula's mass. Okay, so obviously that's 3. So the molecular formula, to find that, we're going to simply take our empirical formula and times it by 3. So this becomes C3H6O3. Okay? So that's how we do one of those problems. Now we can go through and do a whole, kind of combine the two together to find, to do another problem here. Okay, so a compound is found to be 40% carbon, 6.7% hydrogen, and 53.5% oxygen. Its molecular mass is 60 grams per mole. What is the molecular formula? So here we weren't given the empirical, so that's what we have to find first. So we're going to start by assuming that there's 100 grams of our substance. So we've got 40 grams of carbon. Oops, and I moved things all of a sudden there real quick. 40 grams of carbon. Okay, and 1 mole of carbon, there are 12.01 grams. That's going to equal, we have to find our empirical first. Then we have 6.7 grams of hydrogen. In 1 mole of hydrogen, we have 1.01 grams. And then we have 53.5 grams of oxygen in 1 mole. Okay, in 1 mole we have 16.00 grams. So we're going to do the same thing that we did. We're doing the same thing that we did to find empirical formula here. So 40 divided by 12.01 equals 3.33. Okay, then we do, our next one is going to be 6.7 divided by 1.01, and that'll be 6.63. 6.63. And then after that we have 53.5 divided by 16. And that gives us 3.43 moles. So all those were moles. We just calculated moles. We did that so we could find our empirical formula. We're not done yet, though. We have to divide by the lowest number of moles. So 3.33 divided by 3.33 and divided by 3.33. And we really don't even need a calculator for these here. Okay. That's going to be 1, that's going to be roughly 2, and that's going to be roughly 1. So our empirical is CH2O. Okay. Which is the same one that we had earlier. Okay. In the previous problem, we can zoom up real quick. Okay, same empirical formula as before. So we know what its molecular mass is. We know that the molecular mass of CH2O, that just empirical formula, is 30.3. We know that our molecular mass for the molecular formula is 60 grams. So we're going to take 60 divided by 30, and that equals 2. So our molecular formula for this problem is C2H4O2. Okay, so there you go. Just a little bit of review over molecular and empirical formulas. Hope that helped you out. I will catch you later.